how many sandwiches can you make from the following information? You've got 4 choices of meat. I know you guys are probably all hungry. 4 choices of meat and 3 choices of bread. What would you do? Why?
Just put it on between.
Well, it doesn't matter how many, because I want the roast beef.
Because you have, for each one of these, there's 3 possible values.
Can you put 2 meats in one sandwich?
No,
Why not?
because I said so.
Okay.
When you work it all out,
Then 3.
if you made a diagram, which nobody is in their right mind would ever do, you would get 12 possible ways of doing it. Now, as you get into this stuff, this is kind of like the idea of when there's a problem, I know I have it, I'm working on writing it out for you guys tomorrow, how many selections you can get when you're at Subway. A lot. What's that? I hope you have a lot of money. So here's what's going on. I was going to say make a diagram, then I had turkeys and salamis and roast beefs and ham and some breads. And I was going to put turkey on white, or white on turkey. Right. Yeah, I thought it was funny. Turkey bounces. But anyway, what happens here is this is called the fundamental counting principle. And all this means is when you have 2 possible events, and what I mean by events, we're looking at choosing bread, you're choosing sandwich meat. Well, there's 4 meat, 3 breads, it's 4 times 3. If there were 3 choices there, bless you, you had meat, bread,
Veggies.
and 5 types of cheese.
Okay.
So you have meat, 4 of those, 3 breads, 5 cheeses, that would give you 60. Okay, see how fast these things compound themselves out. That's kind of what we're doing today. Real simple stuff like this. Again, if you have meat, we had the 4 meat. Bread was 3. That's all it is. It is extraordinarily straightforward. Right. When things start to get a little bit interesting is when you can use it for sketching. Say someone stole your calculator and they were a masked man. You go down to see Lockhart. Lockhart's got his book of perps. Making stuff up. And in that perp book, there are 195 hairlines, 99 eyes, 89 noses, 105 mouths, and 74 chins.
Oh, wait, you forgot.
Ears and it's combined. It's this.
Oh.
How many different possible bad guys did you come up with? A big number.
Wait, I got
You get really big number. Meaning you'll never find your calculator. Well, what happens if this person was just wearing a mask? What happens if
Then you just do that.
if you just had the eyes and you had a ski mask? It's kind of what I'm getting at.
Eyes and nose.
No, I don't, but I'm gonna make one.
You get 1.334598665 times
You don't get this kind of information in any other class. Make it a ski mask. Paper. Oh.
Oh, God.
Well, there's the chance. That's a good look. What if the person was wearing a ski mask or a welding mask, and this is all you saw? Then there would only be. It's still a little smaller big number.
It's only 8,000.
Because you saw the eyes and the nose. You mean there's just one option for both of those. I thought it was funny. You get the idea though, right?
Yeah.
This is kind of the idea of where the choosing how many different possible lottery numbers are starting to come from. So let's use this in terms of license plates. When you have a license, this is where it gets hard, yes. When you have a license plate, if you're in New York, you've got 3 numbers and 3 letters. That's their standard plate. If you have 3 numbers and 3 letters, how many different license plates could you get if you do not, or sorry, if you can repeat your numbers? So let's think about this. If you have, how many choices would you have for the first one? 10. How many choices would you have for the second one? 10. How many choices would you have for the third one? Okay.
You did 10, 9.
You can repeat them.
Oh, you can.
All right, I'm saying you can have with repetition here. And how many letters are there then?
Wow. God, I have not looked at these things before.
So that means if you are allowed to repeat things, you still have a lot of different possible answers. A lot of different license plates. I think it was somewhere in the neighborhood of 17 million.
1 million. No, never mind.
Yeah, 17 million.
Big number.
You get that.
Yeah.
Okay. Now what happens if you cannot repeat? Now, Gun, this is where you were going.
Oh.
If you can't repeat them, you have 10 choices for the first one. How many are left for the next? Whoa, 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 not 7 now. Those are your letters. Or now you have numbers. Now go to your letters. How many letters are there?
26, 25. And you get 11
How much you get?
million.
11 million.
You're at 30,000.
11 million-ish.
Now, why would you be able to repeat?
It's just one of those
Just
things.
some arbitrary reason.
Yeah,
The states
Millish? 11 millish?
million-ish. Again, the math here isn't difficult. You're pressing buttons on your calculator. You're not multiplying this stuff out. What I wanted you guys to see here is the differences of possibilities that occur when you have restraints on it without repetition. And that's where the picking of the lottery numbers come from. I think we talked about this. Remember the Powerball simulator I had last year? Well, that website's gone now. I can't use it for the bump. I don't know. I just went to go use it last hour, and it was gone. It's no longer there. When we're talking about like lottery numbers, if you're looking at the Powerball, you have to pick 5 numbers and then the Powerball. There are 56 numbers in the Powerball, and then 56 of them again for the separate ball part. Now you can't repeat the numbers, can you? So the possible combination, or the possible that you get, and then you have to multiply that again by the 56, because that's the Powerball. So you've got all of these in one hopper, and then this is in a separate hopper. So you multiply that out, and you have a snowball chance in HE double hockey sticks to win.
Did you ever win the?
2.
I don't know.
I did. I did after 200 some odd thousand years.
To make a profit?
After 200 some odd thousand years, yes. At that, and I apologize that the website's not working anymore. I'm trying to find a new one. When I ran that Powerball simulator, it was basically running through instantaneous picks yearly. It was picking, 10, 20 years every 3-4 seconds. And it just constantly ran. During the course of a day, it would go through a couple thousand years worth of picks. Well, I had it running for months and months. And eventually it wound up winning after I had spent, I want to say I spent in the neighborhoods of around $80 million on lottery tickets. Obviously, I won the Powerball. I won $500 million. But prior to winning the $500 million, I had spent 80 some odd $million, and I made like $1 million. So my return on investment was like 8 cents on the dollar. It really wasn't worth it. And it took, according to the computer, it took a little over 200,000 years for me to win the lottery.
So far, with the matter.
Congratulations.
So, yeah, congrats, I'm still here, right? If you think about how much time elapsed in 200,000 years, 200,000 years ago, were we even walking yet? I think we were, weren't we? Or were we still upright-ish?
I don't know.
We got really big foreheads and went, ooh, a lot.
Probably.
What? Oh, that was funny. That's almost as funny as this.
That's just.
These look like a-
Teach the
I
entire
need to get
class.
some string, yeah.
Teach the entire class of
For the
that.
next class, and that can be your lead until like the next.
I need string. Yes, I'm gonna go. I'll run into the classroom and steal it, steal something and run away. What are you doing 12th hour?
I have humanities, but I'm with my.
Running in with the mask and stealing someone's calculator.
I ate last hour.
So now let's do this a little bit differently.
I
How many different ways can you arrange the letters A, B, C? How many different ways can you rearrange the letters A, B, and C? No, put them in that order. Think of it this way.
Oh, wait. So like, you have like
So here's A, B, C. That's one way. B, A, C, that's 2. A, C, B is 3. 4. And which one am I forgetting? Any that one?
put the B on the other side.
Cow.
So what's happening here is that order is mattering. Because when you think about the first letter, how many different, there's 3 spots, right? There's 3 possibilities for this one, there's 2 possibilities for this one, and 1 possibility for that. So what's 3 times 2 times 1? Do you know what this is called? What is it? No. Well, it is a permutation, but what does it mean when you do 3 times 2 times 1? Do you know what that symbol is?
Oh, the chapter.
countdown.
Three factorial. 3 exclamation point. 3's not yelling at you. It's telling you 3 times 2 times 1. Yeah, it's not going 3! No, it's not doing that. And permutation, a permutation is ways of arranging things that the order matters. When you have a selection where you have to put something in the first spot, something in the second spot, and it can't be duplicated, and so on. So you wind up using what this is called permutation. They use factorial. Factorial is just 3 times 2 times 1. If it's 7 factorial, that's 7 times 6 times 5 times 4 times 3 times 1. One of the weird ones, though, is the following factorial.
Oh.
What is it, 0?
Oh, 0, 0, 0.
Why?
That is one of the weirdest.
How does that equal 1?
What is anything to the 0 power?
Oh, 1.
It's kind of along those lines. So,
I don't understand why though.
Yeah.
it's because you're dividing by itself.
I wanted this thing.
Look one up.
Whenever you have something to the 0 power, you're divided by itself. Because when you go to the negative power, it just brings below the degrees change. So you use permutations when things with order matter. Let's say we are all Olympic ski jumpers, and there are 12 of us because the other half of you guys aren't any good. And we want to figure out how many different ways could the 12 of us finish in the Olympics. Well, if you're finished in the Winter Olympics, you're probably going to do well. Finn,
Ah.
Nordic. I don't think Doug was amused at that one.
I am not amused.
Wow. Anyway, so
What?
no, just the look on your face when I said if you're finished in the Winter Olympics, you probably did well. But you just looked at me like I'm just a complete and total moron. More so than normal. So if you have 12 people, obviously to win, there's 12 spots. To come in second, there's 11. So on.
What about the other people?
Well, we're taking there's only 12 people in this event. So what is 12 factorial according to your calculator? Well, there's a button for that.
Well, it is, and I found.
You type 12, then you hit math. Move to the left once. It's number 4.
12.
Wait,
Exactly.
is it three?
Oh, that's
Wow.
wow.
5, 6, 7, 8, 9.
So that means electric company?
It's
that.
Yeah.
math. Number.
So 12 factorial gives us a very big number. For 12 people to be in one event, there are over 479 million ways that you could finish that race. That's a lot. I'm not a very smart person, but 479 million is a big number.
And to get
Do
one.
you know how long it would take you to count to 479 million?
A long time.
All right, well, let's think of this.
A computer can count it.
Who's got a stopwatch?
Me.
I got one.
So, as ridiculous as that sounds, it's just one of those things that you can do. Now, the weird part of this comes in now is how do you pick the top 3 finishers? You don't. You let somebody else do it. So if you have 12 people, to start the race, how many different ways can you get 3 people to be the top finishers? Well, how many spots do you have for the 3 winners? You have 3 spots. You have, how many different ways can you put them in the first spot? There's 12. How many are next? 11. Then how many? Okay. So the way that you're able to pick 3 out of that 12 to be the top 3 finishers would be that. Substantially less. What is it, like 11 or 11 or 13? What was it again, sorry? 1,320. That's still a lot of different ways of being able to do that. But what you just did was called a permutation where order mattered, where you just picked 3 winners out of the 12. Yes, sir?
We can use like the NPR and NCR.
That's where this comes from. That's where this comes from. Because this, where you chose, we had 12 permute 3 is what you just did. That means the following. 12 factorial divided by 12 minus 3 factorial. Well, 12 factorial, we all agree, is 12 times 11 times 10, blah, 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 times 1. You agree? Over here, what's 12 minus 3? 9 factorial would be 9 times 8 times 7 times blah, blah, blah.
So they just cancel out.
So they just cancel out. So the 9 on down, and that's why you're left with 12 times 11 times 10. It's called a permutation. Again, there is a button on your calculator to allow you to do that. What you do is you type 12, math, left, 2, 3.
Wait, is it actually 2? Oh. And then you press 4.
That was for factorial.
NPR.
NPR is what it's
Using
Number of, yes.
I did it 2.
It's the total number over how many you're picking. You're picking 3 out of the 12. So it's 12 permute 3.
Is there a short?
No, there isn't. There is no alpha shortcut for that one. Again, what we're looking at here, guys, is order matters. they have to be within a specific order. The way that you choose that out or pick that out is going to be when you have races and things like that.
Yeah.
Again, like I said, order matters, NPR, blah, blah, blah. Your calculator has a button. Do you need to know how to use the formula? You are considering going to 10 colleges. Before you decide to go to college, you want to visit some or all of them. So how many different ways can you go to 6 of them? Well,
60?
no. There are 10 total.
I want to say
251,000.
151,000.
One on the left.
1,100. There.
So in other words, there's a lot of different ways to choose to which one order to go to see them. Yes, ma'am.
So, like for this, you can tell that you have to, you only need 6 slots, but how would you know that you don't have to say how many you have to?
No, because they will say it's worded very straightforward. There's really not a lot of loophole in this one. Okay? There's not working backwards into this. Because I'm sure that's what you guys. Pretty soon you guys are wondering, when is it going to do this?
Yeah.
Yeah.
No.
Okay.
No.
It doesn't do that?
No. It doesn't do that. We probably could.
No.
Oh,
I think I just try my luck and type in a bunch of random numbers.
You probably would do okay. Now, with the other one, if you wanted to do all 10 colleges, well, that's again, it's 10. You're picking 10 of them. That winds up being
3,628,800.
there's a lot of different ways to go do that. 10 permute 10 is the same thing as 10 factorial. Works out to be the exact same. All right. Now the weird one. What we're gonna do here is pick letters, or how many different ways you can arrange letters. But this time we're gonna allow for repetition within the letters. So in the example of having the word Ohio, how many letters are repeated? One letter is repeated twice. Okay? So in the word Ohio, how many total letters are there? Okay. So there's 4 total letters, and I'm going to divide that by, there's only one letter that's repeated. It's repeated how many times? Twice. So 4 factorial divided by 2 factorial is 12. There are 12 different ways you can rearrange those letters.
I was doing 4 divided by 2.
Yeah.
Don't do that. Like, no.
Okay? If you're talking about Mississippi, remember how cool it was when we first learned how to spell Mississippi? M-I-S-S-I-S-S-I-P-P-I, yeah.
Hey, what has 4 eyes and can't see?
Dog.
No,
Is it
let's not even ask.
Why is it divided by
Don't answer.
See how this letter is repeated twice?
Oh.
That's one.
Oh, so like the S's and the
Yes.
I's and the P's,
Now you change your word.
With the S's and the I's and the P's, well, how many total letters are there in Mississippi?
Oh my god.
12.
There's 11.
Yeah.
So it's 11 factorial divided by, well, the I's are repeated 1, 2, 3, 4 times. The S's are repeated 1, 2, 3, 4 times. And the P's are repeated twice. Your calculator, if you type it in exactly like that, it'll spit out the answer. You can put factorials with fraction bars, it's not a big deal. So you do alpha, y equals 11 over 4.
34,600.
I got 0.
3, 4, 6, 5, 0.
Just minus 614.
There are 34,650 possible permutations, excuse me. I always have a problem saying combination when it's permutation. There are two different things. Combinations when we're talking about tomorrow, that's when order doesn't matter, and that gets a little bit messier because you can start doing some pretty crazy stuff with combinations. Permutations are very straightforward. Okay? Let me give you some more. I'll put this up on the board for those slackers that don't have a book on there because this should take you about 7 minutes. If it takes you more than 3 minutes to do the first set of problems, it means you had to get up and go find batteries for your calculator.
What if I
You only have 6 minutes.
Well, you should get all those done.